Hi everyone, welcome back to this playlist. I hope you're as excited as I am to dive into today's session. If you're new here, no worries, this is part of our ongoing journey to explore the fascinating world of technology. Today, we're going to unpack some big topics: artificial intelligence, machine learning, deep learning, large language models, neural networks, generative AI, NLP, and more. Let's get started. What is artificial intelligence, AI? So, what exactly is artificial intelligence? In simple words, AI is like teaching a computer to think and act a little bit like a human. Imagine giving a machine the ability to make decisions, solve problems, or even recognize things, all without us telling it every single step. Pretty cool, right? Now, let's dig deeper. AI is a broad field where we create systems that can perform tasks that usually require human intelligence, like learning from experience, understanding language, or spotting patterns in data. These abilities make AI so powerful, and we'll see them in action with some everyday examples. There are different types of AI. Narrow AI, this is what we use every day. Think of Siri helping you set a reminder or Netflix suggesting your next binge watch. General AI, a futuristic idea where machines can do anything a human can. We're not there yet. Super AI, an even wilder concept where AI surpasses human intelligence, straight out of sci-fi movies. Let's check out some examples of AI tools in action: Google Maps, spam filters, and chatbots. Here's how they work their magic and show off those human-like skills. Take Google Maps. For instance, it uses AI to find the fastest route for you. In simple terms, it's like a super smart friend who looks at traffic, roads, and distances to figure out the quickest way to get you somewhere, just like a human might plan a trip, but way faster. Behind the scenes, Google Maps taps into AI algorithms, often boosted by machine learning, to analyze real-time data like traffic jams, road closures, and past travel times. It learns from past experience by studying historical trips, like how long people took to drive a route on a Tuesday at 5 p.m., and uses that to avoid slow roads during rush hour. It also understands language when you say, "Take me to the nearest coffee shop." Figuring out a nearest means distance and a coffee shop is your goal, just like a human getting your request. Plus, it's great at spotting patterns, like noticing a highway always clogs up at 8 a.m., so it suggests a better path. That's AI because it's not stuck to a rigid rule like always take the highway. It learns, adapts, and makes intelligent choices, mimicking a human navigator. Then there's spam filters, your email's way of knowing what's junk, all thanks to AI. Picture it as a clever librarian who reads your emails and tosses the junk ones into a trash pile before you even see them. It learns what's spam by studying examples of good and bad emails from the past. In more detail, spam filters often rely on machine learning, a flavor of AI, to sift through email content, sender details, and even your habits. They've been trained on huge piles of emails labeled spam or not spam, so they've learned from experience that phrases like "win a free iPhone" are trouble. They understand language by breaking down words and phrasing, like spotting that urgent, "claim your prize" sounds fishy compared to "hey, let's meet at 3, and they're pros at spotting patterns, like lots of exclamation marks or shady links that scream spam. When you mark an email as junk, it uses that feedback to get smarter, adapting like a human who learns to spot scams after being tricked once. Finally, we've got chatbots, like those customer service bots that answer your questions. Think of them as friendly robot assistants that listen to what you say and reply with helpful answers, almost like chatting with a real person. There are two kinds: simpler ones follow predefined scripts, and smarter ones learn from conversations. For the basic ones, if you say "track my order," they understand your language by matching keywords and respond with something like "enter your order number." That's AI mimicking human decision-making with clever rules. The advanced ones, powered by machine learning or large language models, take it further. They've learned from past experience, trained on thousands of chats, to predict what you need when you say "where's my package?" They spot patterns, like noticing "where's my stuff," often ties to tracking questions, and they generate natural replies, understanding the context like a human would. Whether rule-based or learning, Chatbots show off AI by handling conversations, learning from past chats, grasping your words, and recognizing question patterns, tasks that usually take human smarts, all without needing constant hand-holding. What is machine learning, ML? Okay, moving on to machine learning, or ML. In simple terms, ML is a way to make machines learn from data without us telling them exactly what to do. Imagine teaching a kid to recognize cats by showing them pictures instead of writing a rulebook. That's ML. Now, let's dive in deeper. ML is a subset of AI, all about feeding data to a system and letting it figure out patterns or predictions on its own. Unlike broader AI, which might use fixed rules, ML thrives on learning from examples to get smarter over time. For instance, if you show an ML model tons of cat photos, it learns what a cat looks like and can spot one later. Let's see this in action with some cool examples: Spotify, fraud detection, and weather prediction, each one showing how ML works its magic. First up, Spotify. It recommends songs based on what you've listened to, and that's pure ML. Think of it as a music buddy who notices you love pop hits and starts suggesting more of them. Here's how it fits into ML. Spotify feeds its system massive amounts of data, like your listening history, playlists, and even what millions of other users enjoy. It uses algorithms, often something like collaborative filtering or clustering, to analyze this data and find patterns. For example, if you and others who like Taylor Swift also groove to Billie Eilish, the ML model learns that connection and predicts you'll enjoy Billie's songs too. It's not programmed with a rule like Biff Pop, then suggest pop. Instead, it learns from your past listening experiences to make tailored guesses, improving as you listen more, just like ML is supposed to do. Next, there's fraud detection. Banks use ML to spot weird transactions and keep your money safe. Picture it as a super smart bank guard who learns what's normal for you and flags anything fishy. This is ML because it relies on data to train the system. Banks give the ML model tons of past transaction records, legit ones like your grocery shopping, and fraudulent ones like a random $5,000 charge in another country. The model, maybe using something like logistic regression or decision trees, studies these examples to learn patterns, like how fraud often involves odd locations or big, sudden spends. Then, when a new transaction pops up, it predicts if it's shady based on what it's learned, not a hard-coded rule like block all $1,000 charges. It gets better over time as it sees more data, catching new tricks fraudsters try, which is classic ML behavior. Finally, weather prediction. ML crunches past weather data to forecast rain, like a meteorologist who's studied years of storms. In simple terms, it's about looking at what's happened before to guess what's coming next. Here's the ML fit. Weather systems feed ML models historical data, temperatures, humidity, wind speeds, and whether it rained on days like that in the past. Using algorithms like neural networks or regression models, the system learns patterns. For instance, if high humidity and dropping pressure often led to rain last summer, it picks up on that. When today's data comes in, it predicts the chance of rain based on those learned trends, not just a static formula. It refines its guesses as more weather data rolls in, adapting to seasonal shifts or climate changes, showing off how ML learns from data to make smart calls. So, how does ML fit under AI? AI is the big umbrella, any system that acts smart, and ML is one way to achieve that by learning from data. The difference? AI might use predefined rules, like old chatbots, while ML builds its own understanding from examples. Not all AI uses ML. Think of a chatbot with fixed if this, then that responses. It's AI but not learning. A common question: does all AI need ML? Nope. Rule-based AI proves you don't need ML to be intelligent. But with ML, tools like Spotify, fraud detection, and weather prediction show how machines can get smarter by training on data, making them a perfect slice of the AI pie. What is deep learning, DL? Now, let's talk deep learning, or DL. Simply put, DL is like ML on steroids. It uses something called neural networks to mimic how our brains work. Imagine a super smart system that can learn really complex stuff from huge piles of data. Here's the detailed version. DL is a subset of machine learning, taking things up a notch by using layers of neurons. We'll get to neural networks later, to process data in a way that's amazing for things like images, speech, or text. Unlike simpler ML, which might use basic rules or patterns, DL dives deep into massive datasets with lots of layers, making it perfect for tricky tasks. Let's see it in action with some examples: face recognition, self-driving cars, and voice assistants, all powered by DL's brain-like power. First up, face recognition. Your phone unlocks with your face, and that's DL doing the heavy lifting. Picture it as a genius photo expert who learns to spot you in a crowd, no matter the lighting or angle. Here's how it fits into deep learning. Face recognition uses deep neural networks, often something called convolutional neural networks, or CNNs, designed to handle images. These networks are trained on millions of face photos, learning to break down features like your eyes, nose, or jawline into tiny pieces across multiple layers. Each layer digs deeper, first spotting edges, then shapes, then full facial patterns, until it can tell you apart from anyone else. It's not just matching a checklist like 2 eyes, 1 nose. It learns complex patterns from raw pixel data, tweaking itself over time to get super accurate, which is what makes it DL, not just regular ML. Next, self-driving cars, like Teslas, use DL to see the road and drive safely. Think of it as a robo-driver with eagle eyes, figuring out lanes, signs, and pedestrians on its own. This is deep learning because it relies on deep neural networks to process crazy amounts of data from cameras, radar, and sensors. For instance, a CNN might analyze video feeds to recognize stop signs or lane lines, while other networks handle depth perception or motion prediction. These models are trained on millions of driving clips, highways, city streets, rainy days, you name it. The layers of neurons learn to spot patterns, like how a red octagon means to stop, and make split-second decisions, like slowing down for a pedestrian. Unlike simpler ML that might use basic rules, DL handles the messy, real-world chaos by learning directly from raw data, making it essential for something as complex as driving. Then we've got voice assistants, like Alexa, understanding you thanks to DL. Imagine a buddy who listens to your voice and knows exactly what you mean, even if you mumble. Here's the DL fit. Voice assistants use deep neural networks, often recurrent neural networks or transformers, to process audio and turn it into words. They're trained on massive datasets of spoken language, people saying "turn on the lights" in every accent imaginable. The network's layers break down sound waves, first picking up basic tones, then syllables, then full sentences, learning to filter out background noise and guess your intent. It's not just matching preset phrases like older systems. DL lets it learn the nuances of speech from scratch, adapting to new voices or slang over time, which is why it feels so smart and squarely in deep learning territory. So, DL comes under ML because it's a more advanced way to learn from data, using neural networks with tons of layers. The difference? ML might use simpler methods like decision trees, while DL needs big data and computing power to shine. A common question: does all ML need DL? No way. For example, medical systems predicting diagnoses might use decision trees, no neural networks required. Another one: is DL only for images? Nope. It's also used for text, like in translation apps, or audio, as we saw with Alexa. Face recognition, self-driving cars, and voice assistants show DL's power, handling complex, messy data with brain-like learning that simpler ML can't touch. What is a large language model, LLM? Next up, large language models, or LLMs. In simple terms, an LLM is a super smart system that understands and generates human-like text. Think of it as a brainy friend who's read every book ever and can chat with you about anything, except it's a machine with a knack for words. But why large language model and not just language model? That large part comes from the massive scale, billions of parameters and insane amounts of training data, that make these models so powerful compared to older, smaller language systems. Parameters are like the knobs and dials in the model's brain, tiny settings that get tuned during training to figure out how words connect. For example, a small language model might have a few million parameters, but LLMs like GPT-3 rock over 175 billion. That's a mind-blowing number of adjustments, letting it learn everything from grammar quirks to deep meanings across mountains of text, like web pages, novels, and tweets. They're not just basic word predictors spitting out the after a cat, they're giants built to handle complex language tasks. So, what can they do? LLMs can write essays, answer questions, translate languages, summarize texts, generate code, even crack jokes, pretty much anything involving words. The secret sauce behind their popularity? Transformers, a special kind of tech we'll peek at later that takes them to the next level. Transformers are like a superpowered spotlight for language, letting the model focus on the right bits of a sentence to nail the context. Older models might guess the next word by looking at just a few words before it, but transformers can look at the whole sentence, or even paragraphs, at once. They use something called attention to weigh what's important. Say you're reading "The cat on the mat slept all day," a transformer knows cat and slept are other key players, not just mat, because it tracks how words relate across distances. This makes LLMs crazy good at understanding tricky stuff, like sarcasm or long-winded questions, and it's why they've exploded in popularity. With billions of parameters fine-tuned by transformers, they're not just memorizing phrases, they're learning the flow of human language like a pro storyteller. That combo of scale and smarts is what sets LLMs apart. And get this, the number of parameters in LLMs keeps growing year by year, making them even more impressive. Let's take ChatGPT as an example to see this evolution. Back in 2018, OpenAI's GPT-1 kicked things off with 117 million parameters, pretty big for its time, but basic compared to today. It could string sentences together, but it wasn't winning any poetry contests. By 2019, GPT-2 jumped to 1.5 billion parameters, and suddenly it was writing paragraphs and answering questions with way more flair. People started noticing. Then, in 2020, GPT-3 blew the doors off with 175 billion parameters, turning it into a text-generating superstar that could chat, code, and even tutor you on homework. ChatGPT, built on this lineage and released in 2022, fine-tuned those billions of parameters further with human feedback, making it feel like a real conversation partner. Each year, as the parameter count climbs, these models soak up more data and get sharper, handling longer contexts, tougher tasks, and weirder questions. It's like watching a kid grow into a genius, and ChatGPT shows how this parameter explosion is pushing LLMs to new heights. Here's the detailed scoop: LLMs are part of deep learning, trained on massive datasets, like billions of web pages, books, and chats, to predict and create natural-sounding language. They're built on neural networks, specifically deep neural networks, which are like stacks of interconnected brain cells processing data layer by layer. These networks start with raw text, break it into tiny pieces, like words or even smaller bits, and pass it through layers that learn patterns, simple ones like word pairs, then complex ones like sentence meaning. Transformers supercharge this by adding an attention trick, letting the model weigh which words matter most in a sentence, like focusing on the dog, and barked in the dog barked loudly to get the gist. That's why LLMs are so popular. They're not just memorizing, they're understanding and generating text like never before. So, how do LLMs differ from AI as a whole? AI is the big umbrella, any system that acts smart, like a robot vacuum avoiding walls or a chess program. LLMs are a specific slice of AI, focused only on language tasks, powered by deep learning. AI might use rules or simple logic, like an old chatbot with "if this, then that" replies, while LLMs rely on massive neural networks to learn from data, making them way more flexible and creative with words. Not all AI is an LLM, but every LLM is AI, tuned for text mastery. Now, let's talk neural networks and LLMs. They're connected because LLMs are built on deep neural networks. Think of them as a huge web of nodes, or neurons, linked together. Each node processes a bit of info, like a word's meaning, and passes it to the next layer. In a deep neural network, there are tons of these layers, sometimes hundreds, getting more abstract as they go. Early layers might spot basic stuff like "this often comes before a noun," while deeper ones figure out "I love my dog" means affection, not dinner plans. Transformers make this web even smarter by linking words across a sentence, so the model knows he ran fast ties back to whoever you mentioned earlier. This deep, interconnected setup lets LLMs handle long, tricky texts that simpler models can't touch. Let's see some examples: ChatGPT, Google Bard, and Grammarly, all LLMs in action. ChatGPT fits as an LLM because it's trained on a giant pile of text to predict what comes next, using a deep neural network with transformers to chat, write stories, or solve problems. It's not just parroting, it generates fresh replies based on patterns it's learned, like finishing your sentence with flair. Google Bard's another LLM, also built on deep networks and transformers, soaking up web data to answer questions or whip up creative text. It's like ChatGPT's cousin with a different style. Grammarly uses LLM Tech 2, trained on perfect sentences to spot errors and suggest fixes. Its deep neural network learns grammar rules and style from tons of examples, not hard-coded lists, so it adapts to your writing quirks. All three lean on that large-scale and transformer-powered deep learning to shine at language. Oh, and here's the exciting part: throughout this playlist, we're going to dive into LLMs hands-on. We'll cover how to code them, build mini-versions with Python and tools like PyTorch, and peek under the hood at transformers, all with practical examples. Stick around to see how these word wizards are made. What is natural language processing, NLP? Now, let's explore NLP, natural language processing. Simply put, NLP is how computers understand and work with human language. It's like teaching a machine to read, write, or even listen to us. Pretty amazing stuff. In more detail, NLP is a field that blends AI, sometimes ML, and even deep learning to process language, making sense of words, sentences, or conversations. It's been around longer than LLMs, stretching back decades, starting with basic rules and growing into the smart systems we have today. Let's check out some examples: Google Translate, sentiment analysis, and speech-to-text, all showing off what NLP can do with language. First, Google Translate. It turns English into Spanish or any language you want, and that's textbook NLP. Think of it as a magic translator who listens to your words and flips them into another tongue instantly. Here's how it fits into NLP. Google Translate is all about understanding and generating human language. It takes your input, like "I love my dog," and processes it to grasp the meaning, then spits out "amo a mi perro" in Spanish. Early versions used rule-based tricks, like dictionaries and grammar charts, but now it leans on machine learning and even deep neural networks to learn from millions of translated texts. It's NLP because it bridges human languages, figuring out sentence structure and word meanings to make translation smooth and natural, just like a human interpreter would aim for. Next up, sentiment analysis. It figures out if a review is positive or negative, straight up NLP in action. Picture it as a vibe checker that reads your movie review and knows if you loved or hated it. This fits NLP because it's about computers understanding the emotion behind language. Say you write, "This film was amazing." Sentiment analysis scans the words, picks up on amazing as a positive clue, and labels it a happy review. It's trained on tons of text examples, reviews, tweets, you name it, using ML or DL to spot patterns in how people express feelings. Whether it's a simple keyword check or a deep model catching sarcasm, it's NLP at its core, decoding human sentiment from messy, real-world language. Then there's speech-to-text, like dictation on your phone, another NLP gem. Imagine a secretary who hears you talk and types it out perfectly. That's what this does. It's NLP because it's all about turning spoken language into written text. When you say "set a reminder for 3 p.m., it listens to the audio, breaks it into sound chunks, and matches them to words it's learned from huge speech datasets. Modern versions use deep learning, like neural networks, to handle accents, background noise, or fast talkers, converting your voice into text accurately. It's not just hearing, it's understanding what you mean and writing it down, a classic NLP task that mimics a human taking notes. So, what's the difference between NLP and LLMs? NLP is the broader goal, making machines handle language in any way, while LLMs are a modern, powerful tool within it, using deep learning for text mastery. NLP is older because it started with simpler systems, like rule-based translators, way before LLMs and their billions of parameters came along. A common question, is NLP the same as LLM? Nope, NLP covers basic stuff too, like spell checkers with no fancy learning, while LLMs are the heavy hitters for big language tasks. These examples, Google Translate, sentiment analysis, and speech-to-text, show NLP's range, from translating words to feeling vibes to typing your voice. What is generative AI? Let's talk generative AI, or GenAI. In simple terms, it's AI that creates stuff, like text, images, or music, out of thin air. Imagine a robot artist or writer whipping up something brand new just for you. It's a combo of deep learning and sometimes large language models working together to generate content. Let's see it in action with some examples: DALL-E, Midjourney, and ChatGPT, all shining stars of GenAI that make cool things from scratch. Here's the detailed version. Generative AI uses models like LLMs or other deep learning systems to produce totally new content, not just analyze or copy what's already there. It's trained on massive datasets, think millions of images, sentences, or songs, so it learns the patterns and rules of how things look or sound. Then, it takes a little nudge, like a text prompt or random seed, and starts creating. For instance, with deep learning's neural networks, it might learn how brushstrokes form a painting or how words form a story. LLMs, with their billions of parameters, are perfect for text because they've mastered language structure. Think of them as word wizards spinning tales from data they've gobbled up. Other DL models, like GANs, generative adversarial networks, pit two networks against each other, one generating, one judging, to perfect things like images. Whether it's text from an LLM or art from a GAN, GenAI's magic is in crafting something original, not just parroting back what it's seen. That's what sets it apart. It's a creator, not just a calculator. So, how do deep learning and LLMs team up in generative AI? They're like a dynamic duo. DL is the mastermind building the foundation, and LLMs are the language specialists adding the finesse. Deep learning provides the heavy-duty neural networks, layers upon layers of the neurons that crunch raw data like text or pixels into something meaningful. It's the engine that learns complex patterns, like how sentences flow or what makes a face look real. LLMs, being a type of DL model, take this further for language. They're packed with billions of parameters tuned on huge text datasets, letting them predict and generate human-like prose. In GenAI, DL might power an image generator, while an LLM handles text prompts to guide it, like telling an artist what to paint. Together, they blend raw processing power with language smarts, creating everything from chat replies to artwork. For example, an LLM might describe a dragon in a storm, and DL turns that into a vivid image, collaboration at its best. Now, let's break down the examples. DALL-E is generative AI at its wildest. It turns text into images, like a cat in a spacesuit riding a rocket. It fits GenAI because it creates brand new visuals from scratch. Trained on heaps of image-text pairs, its deep learning model, using transformers and diffusion techniques, learns how words match pictures. You give it a prompt, and it generates a unique image, not just stitching old ones together. That's pure generative magic. Midjourney's another GenAI gem, making art from text prompts, like a futuristic city at sunset. It's built on DL neural networks, inventing stunning visuals from scratch. It's generative because it dreams up scenes no one's seen before, pulling from learned patterns, not copying a photo album. Then there's ChatGPT. Yep, it's GenAI too. It writes poems, scripts, or chats, creating fresh text every time. As an LLM powered by deep learning, it's trained on a sea of words to predict and generate responses. Give it write a sci-fi story, and it spins an original tale, not a reprint. That's the generative spark at work. A common question, is all AI generative? Nope, some AI just analyzes data, like spam filters spotting junk mail. GenAI is special because it creates, thanks to DL and LLMs teaming up. Tools like DALL-E, Midjourney, and ChatGPT show how it brings imagination to life, whether it's pixels or prose. What is a neural network? Alright, neural networks. Simply put, a neural network is like a computer brain made of tiny connected units called neurons. It's inspired by how our brains learn, taking in info, processing it, and spitting out answers. In detail, it's a system of layers that crunch data, input goes in, gets transformed through hidden layers, and output comes out. Think of it as a sandwich. The input layers the bread, hidden layers are the tasty filling, and the output layers the other slice, sealing the deal. Let's break it down with an example and see how it ties to AI, ML, DL, and LLMs. Here's how it works. Imagine you're training a neural network to recognize cats in photos. The input layer takes the raw data, like the pixels of a picture. Say it's a 100 by 100 image, that's 10,000 pixels, each with color values, fed into the input layer as numbers. Those numbers zip to the hidden layers, where the real magic happens. These layers, there could be dozens, process the data step by step. The first hidden layer might spot edges, like the outline of a cat's ear. The next layer combines those edges into shapes, like the ear itself. Deeper layers might figure out it's a furry face. Each neuron in these layers is like a little worker, tweaking numbers based on patterns it's learned from tons of cat pics during training. Finally, the output layer gives the verdict, say, 90% chance this is a cat. The input layer passes data in, hidden layers transform it with math and weights, and the output layer delivers the result. They're all connected, passing info forward like a relay race. So, how's it connected to everything else? Not all AI needs neural networks. Rule-based AI, like a simple if hot, turn on AC system, doesn't. ML uses them sometimes, but not always, like decision trees predicting medical outcomes skip them. Deep learning, though? Yep, it's all about neural networks with lots of hidden layers. That's the deeper part, handling complex stuff like image recognition. LLMs? Absolutely, they're built on deep neural networks too, crunching text instead of pixels. For example, in ChatGPT, the input might be your question, hidden layers process the words into meaning, and the output is a clever reply. Want a real-world taste? If an app flags a photo as cat, the neural network's input was the image, hidden layer spotted whiskers and paws, and the output said yep, feline. For deep knowledge, check our neural network playlist, it's a goldmine. Oh, and NLP often uses neural networks now, but older NLP was simpler, like translation apps with basic rules before LLMs came along. It was task-specific, like turning the hellos to Ola, while LLMs go big and broad. Neural networks are the backbone of modern smarts, linking input to output through hidden layers to make sense of the world. What are transformers? Next, transformers. In simple terms, they're a special type of neural network that's amazing at handling sequences, like sentences or time data. Here's more. Transformers used attention to focus on important parts of data, making them perfect for LLMs like ChatGPT. They're connected to neural networks because they're a fancy version of them. Want more details? We'll cover transformers in depth in upcoming sessions, stay tuned. Tools and techniques for LLMs. To build an LLM, you need some tools. Here's the lineup. Python, the coding language, easy and powerful. NumPy and Pandas, for handling data like a pro. PyTorch, a library for building neural networks. Jupyter Notebook, great for testing code step by step. Google Colab, free cloud computing for heavy tasks. VS Code, a slick editor to write your code. Each tool has its own playlist on this channel, go check them out to master them. Now, how does ChatGPT fit in? It's AI, smart system, ML learns from data, DL uses neural networks, GenAI creates text, and an LLM language focused. It's the full package. Let's unpack that. As AI, it's a clever system mimicking human chat skills, think of it answering your wildest questions like a friend. For ML, it's trained on a massive pile of text data, books, websites, you name it, learning patterns without a spoon feeding it rules. Deep learning kicks in with its deep neural networks, layers upon layers crunching words to understand and generate replies, way beyond simple ML tricks. It's generative AI because it doesn't just analyze, it creates fresh text, like poems or code, from a prompt. And as an LLM, it's a language beast, built with billions of parameters to nail conversations, translations, or essays with human-like flair. Take this, you ask it write a sci-fi story about Mars, and its AI smarts, ML training, DL networks, GenAI creativity, and LLM language skills team up to spin a tale, no copy-pasting, just pure creation. It's like a superhero squad of tech rolled into one. And here's the best part, in this playlist, we're diving deep into all things LLM, including ChatGPT, with coding galore. We'll explore how these models tick, from their neural guts to their word-spinning tricks. The first 3 to 5 sessions will be notes-based, laying the groundwork with concepts like these so you get the big picture. After that, it's all coding and practical, think building mini LLMs, tweaking them with Python and PyTorch, and seeing results live. Stick with us to go from theory to hands-on mastery. What do you have to do now? Alright, we've covered a lot. Here's your next step, recap what we've learned, AI, ML, DL, LLMs, and more. Re-watch if you need, it'll click even more the second time. If you enjoyed this, please support the channel. Producing quality videos takes time and coffee, lots of it. You can buy me a coffee via the link below to help me keep going. It means the world to me. Got questions? Think I got something wrong? Have ideas for future topics? Drop them in the comments, I read everything. Let's learn together and grow this community. We'll meet again in the next session, more exciting stuff awaits. Until then, keep exploring, and see you soon.